literal equations. This is an honors topic. Excuse me. So a literal equation is an equation that has more than one variable. So every formula, so all of these down here are examples of literal equations. So every formula is a literal equation. So volume equals length times width times height. Distance is rate times time. Area for a circle is pi times radius squared. Perimeter would be 2 times your length plus 2 times your width. So all of these are literal equations because you're just looking for a specific variable. So on this one, we wanted to find volume. On this one, we wanted to find distance. So depending on what you're finding is going to be which variable you're solving for. So when you solve a literal equation, you're just going to solve for one of the variables. So you'll solve for one of the variables. However, all variables will remain in your answer. So you're not getting rid of any of the variables. You're just trying to get one variable to one side and all the other variables to the other side. All right, so first thing we're going to do, we're going to circle a variable that we're looking for, and then we're going to stick that. It's going to stay there. It's stuck in that position. And then we're going to undo the addition and subtraction first. So we'll undo addition and subtraction first. And then we'll undo multiplication and division. And then we're going to be undoing that because once to this point, we should be able to isolate or get the wanted variable, the one that we want alone. So to start out, we're going to just start and we're going to always solve in these examples that we're going to do, we're going to always solve for x. Sometimes it won't be x, but what we're going to be doing is solving for x. So all of us could take this first example and solve for x. We want to get x alone. So this is what's stuck. So we need to undo adding 6 to both sides. And we would end up with x equals 14. We know this. We've done these before. The only difference is you're going to start getting just letters. So I still only want x alone. Well, the thing that's on the same side as x is this subtraction of n. So before it was subtracting 6. So to get rid of subtracting 6, we added 6. So we're going to do the same thing, but we're going to add n. That will still zero it out because whatever this is now is canceled. And I'm going to add n to this side. But you'll notice I'm not going to put it underneath here because they are not like terms. These were like terms, so I could just add them straight down. But I am not going to put that next. So you can either put it next to it like this, or you can put it down here like this. But it cannot go underneath because they're not like terms. Now that zeros, leaving me with x, which is what I wanted to solve for, equals 8 plus n. I still don't know what x is. I don't know what n is, but I know that if I can find n, I can then solve for x. So all I'm doing is getting it so that my variable is alone. So it's telling me whatever x equals is this. I may not know exactly what those letters are, but that's what x equals. So now we've gone from, like our first one had just x, then this one, our second one has 2 variables, and now our third one is all variables. It does not change. I still only want this alone. So I'm going to add y, and I'm going to add y. Still not like terms. These are k's, these are y's, not the same. That will make those 0, leaving me with x equals whatever k plus whatever y is going to be. But in each case, you'll notice I've got my x, or whatever variable I'm solving for, on one side, and anything that wasn't an x is on the other side. I did not keep them all on the same side. Same thing, let's look at D. Our goal is to get x all alone. So right now, I have x being divided by 4. So the opposite of dividing by 4 is timesing by 4. This will give me 1, and then I'm going to times this side by 4, leaving me with x equals 80. Again, x is alone, x is on this side, anything else is on the other. The only difference now is instead of having a 4 down here, I have a d. So I still need to get x alone. So right now x is being divided by d, so the opposite is timesing, which will give me 1. And I got to multiply this side. leaving me with x equals, and a lot of you like to still write it like this, but this is going to be the most correct form, just 20d. Either one's acceptable, just the most correct. Again, x is all alone, everything else is on the other side. Our final one, everything again is variables. I still need to just get x alone. So on the same side of x right now is being divided by d, so the opposite would be timesing by d, giving me 1, and then multiplying this side by d, leaving me with x equals c times d, or the most correct way, cd. Again, x is alone on one side, or whatever I'm solving for is alone on one side, everything else moved to the other. All right, and then we have G, H, and I. G, H, and I, we're still going to be solving for x, but these ones are a little bit more intense, so I didn't just start out with simple. Our goal, I need to get that x alone. Well, the only thing that's on the same side as x is being multiplied by x, so I have x times a. Well, the opposite of timesing is dividing, but we need to divide. You can either divide it all like this, or if it makes you feel better, you can divide it like this, because everything has to be divided by a. So your final answer, this will give me 1, would leave me with x equals, this would be the most correct way to write it, because it's just saying whatever those are, you're going to add together, or you can write it like this. So now you'd end up with, again, you can write it either way, but both of these need to be divided by a, so whichever way helps you understand it. All right, so again, I need to get x alone. Right now, x is being multiplied by a and b. You can either choose to divide by a and then divide by b, but these two are almost like they're stuck together. So if I divide by ab at the same time, you'll notice I have the same thing on top as I do on bottom, so this will still become 1. Oh, whoops, I can't do that first. I didn't realize that was on the same side. Sometimes we have to draw that. Our goal is to get this x alone, right? But right now, x is attached to a and b, so I have to undo this one first. So I need to move this d over to this side. So to do that, I need to undo and move it to the other side, leaving me with a, b, x, so a times b times x equals e minus d. Again, now here's what I'm saying. This x is being multiplied by both a and b. So I can divide by a and b at the same time, because anytime I have the same thing on top as I do on bottom, it's going to become 1, and then I'm going to divide everything over here. Now x is alone because I have one x left here, and I have e minus d being divided by a over b, or a times b, not a over b, a times b. All right, last one we're going to look at. Again, our goal is to get this x alone. I need x alone. So first thing I need to realize is that right now g and m are attached because they're being multiplied together. So to move g and m to this side, I'm going to subtract g times m. And if I do it to one side, I do it to the other, leaving me with 1/5 x equals e minus g times m. Right now I am timesing by 1/5, so the opposite would be to divide by 1/5. So our final step, and really when we divide, we end up multiplying by the reciprocal, so this is technically not how I would write it, but we're going to divide by 1/5. That will give me 1, and then this would be divided by 1/5 as well. So our final answer would be x equals e minus g times m divided by 1/5. And if you understand the rule, you could have just times that by 5, because that's how it would work out as well.